Hello, everyone. Welcome to Solomon webinar. We are glad to have you here. Today, we will be talking about intelligent solutions that can bring your factory to the future. Let me introduce you your host today. We have the pleasure to have our senior sales manager here, Henry Chen.
Hello, everyone.
And
Nice to meet you.
myself, Jennifer Alvarez. I'm in charge of the Latin America and Southern Europe market. Today, as I told you, we will bringing you intelligent solutions that will bring your factory to the future. Let me start with a brief overview of the agenda. Today, I'll be reviewing the Soul Motion Technology Corporation and a little bit about the robotics history. And then my colleague Henry will be explaining to you a little bit more about the products and the different applications. As general information about this webinar, all the attendees will be muted, so the webinar is smooth. And also, if you have any questions, please feel free to put it in the chat. We'll be seeing them and we'll be answering them at the end of the presentation. So let's begin with this presentation. Solomon Technology Corporation was founded in 1973, and we went public in the stock market of Taiwan in 1996. Currently, we have more than 1,000 employees, and our basic business scope is automation. So we have more than 50 years of experience. Currently, our worldwide offices are in China, Taiwan, Southeast Asia, and also in the US. Coming soon, we will have offices in either Spain or Czech Republic in Europe. Unfortunately, we were not able to open this office last year because this year because of the COVID. However, we are trying to open this office next year. So what is important for you to know about all of our offices worldwide is that we have engineers on site. That means that we have 24/7 support for all of our customers. So I would like to tell you today a little bit about the history of robotics. So we all remember where there was manual operation, where the operator were in charge of managing the machines and the robots. Well, in those situations, the operator usually got really tired and worked long shifts and got injured. But now, then we had the first wave of the first generation of robots, which were only able to pick an object from a fixed position. And that fixed position was due to fixturing, the use of fixturing or a mechanical solution. So we were able only to pick an object from a fixed position. However, then it came the second generation of robots that is the present. And this is the robots that can pick objects that are in a random position. Then we started thinking at Solomon, how can we do eyes? How can we give eyes to the robot? How can we empower that robot and give what it could be human eyes? So that are the solutions that we're bringing today to you. So let me continue by telling you what are the 4 products, our 4 solutions that Solomon brings to you today. First, we have AccuPick. AccuPick is our random beam picking solution. Then we have Soul Motion, which is our vision guided robot solution. Our third software solution is Soul Vision, which is our 2D deep learning inspection solution. And finally, we have our hardware. Our hardware is our 3D scanner that is called Soul Scan. And after me introducing these 4 products, I would like to tell you a little bit of how do we work in how our software works. Solomon Artificial Intelligence 3D Vision software integrates with more than 21 different brands of cobots and robots. And we also don't limit ourselves and our software to work only with one brand of 3D scanners. We work first with our Soul Scan, Solomon 3D scanner, using our technology of structured light, but we are also an open source for other cameras. For example, the 3D scanner of Intel, which is called Intel RealSense, using the active stereo technology, and also Kinect from Microsoft, or other technologies as Wengler. And what is important to know about our software is that our software can act as a master and manage directly and send the coordinates to the robot or the cobot itself, or can also act as a slave, sending the coordinates to the robot controller or to a PLC, as we can see in this image. The communication that our technology uses to communicate as a slave is the TCP/IP protocol. So our AcuPeak data flow, it's really simple. It just has 3 steps. And these 3 steps is first, the sol scan or any 3D scanner takes the scan of the object. It sends all this data of recognition and calculation to the computer, to our software, analyzes it, and then it sends the coordinates to the robot to pick and place the object. Our best-selling 3D scanners at the moment is the Sol Scan using our structure light technology and Intel RealSense using active stereo technology. How AcuPeak works, it's in 2 ways. First, as you can see in this video, we position the 3D scanner on top of the robot. And when the robot moves, the scan takes the pictures of the object. It's as easy as you can see on this video. And the second way AcuPeak can work is eye in hand. This means that the robot is positioned in the arm of the robot. And this could be used for 6 or 7 axis robots. And mainly we use different 3D scanners for accuracy or budget constraints. So in this example of the eye in hand, I want to let you know that we have different types of scanners and we have different types of technology to help you. I want to invite you to visit our website, solomon-3d.com, to visit and know more specifications about our 3D scanners and also our products. So I hope you enjoyed this second part of our presentation with Henry, which will give you more examples and detailed information about our products.
Okay, thank you, Jennifer, for the excellent opening. So from my part, I will really want to highlight our technology, why we use the AI technology to do beam picking instead of 3D matching by CAD base. So we all know in the 99% of the beam picking application, you will like to use the CAD file to match with the point cloud. We call CAD-based localization technology. However, here in Solomon, we used AI technology to input your object's images in 2D, and we learn with our AI modeling tool algorithm to generate different classes in your beam. So in this way, we are reading not only the 3D, but actually we are using the 2D information to locate your parts. We can read more information on the surface. For example, we can see the color, we can see the texture, we can see like human eyes, we can see through those pictures and through a different classification. So we not only combine the 3D technology by our camera, but also the 2D information. So this is how it works. We will collect both the 2D information with the labeling, which you will define in the beginning, tell us our computer how to recognize. For example, here you have the front view, you have the bottom view with the different classes. You can define in the beginning, and our AI will learn it and locate for you. And then the 3D point cloud here, generated by our scanner, will fit with those AI results. In this case, we can successfully recognize where is the parts and what is the front view and what is the bottom view. Also, we can read the text or the different fixture on the surface. So this is the most different and unique solution in the market right now. And I will tell you why we would like to develop the AI vision instead of the 3D CAD file matching method. So first of all, we believe the color and the surface information in 2D is also important for the people when they are doing the bin picking. For example, you have a different color of caps or picking items. You have to differentiate into different classes. In this case, 3D matching by the CAD cannot do it because basically they are also only matching with the shape. But here with the 2D information, we can successfully see the same shape but see through the information on the surface. And the second is we understand in most of case, the CAD file is not really convenient or available in your factory, especially when the product has the variable size or they are not yet in the finalized shape. For example, here the textile is an excellent example. Every textile bobbin has a different size. It could be slightly bigger or smaller. In this case, the CAD matching method will be more difficult and not that precise compared to the AI vision localization method. Also, the food or some soft plastics, something easily to change or the transforming their shape will be highly feasible for the AI to recognize them and match with our point cloud. Also, with the AI localization technology, we are able to see some really complicated shape. All the objects, they are tangled to each other. In this case, if you don't use the really high quality point cloud scanner, you might really get the really messed up point cloud quality. In that case, you couldn't really do the 3D matching for your bin picking applications. And the next one is if you have the transparent or the shining objects, AI will also help you to locate the parts in the beam, even they have the bad quality in the point cloud. So this is some features we want to highlight, and we believe those features will bring you more applications in the industry. And the last one we like to highlight, and also is a trendy application, is using the AI localization technology for the logistics industry. See, those cartons, you will never have the CAD file to match them. What you can do, especially when they are connected together, you don't see the border, you will have to use AI to localize them or segment them in the different let's say the mask you can see in a different color. So by this way, we can successfully pick the center point of those cartons, either do depalletizing or do the pieces picking for the e-commerce. And I will bring you some of the examples in the following pages. Okay, for example, Solomon is dedicated in looking something really small. For example, here we have some chips picking applications. You can see not only we can see through the color, black and golden, but also we are able to recognize the pattern inner pattern here. So we can organize them in the really neat way, not with read with a lot of information on the surface pattern. This is one example. Second customer we implement is for Morgan. Morgan Corporation is dedicated in building up a lot of automotive parts manufacturing. And Solomon has several lines for them to pick up some shiny and tiny clippers. Those are the really, sleepy on the vibrating table. So in the beginning, they try to use vibrating table to separate those tiny parts. But you can see they are not either overlapping or connect together. So in this case, 2D traditional way will give them a lot of trouble to recognize the front view and the back view. You can see here in the picture, we label in the different classes as the front view and the back view. This is how our AI can learn on the surface. So this is really good example we do for the Mergon. And the next one is we do for the Denso. We pick up some auto parts. These auto parts has a complicated features. You can see there are some holes in the front and in the tail. So In the traditional bin picking task, this belongs to the high level task already, because you will easily confuse on the point cloud where is the front and where is the tail. And also when we place, we have to place correctly with the orientation. So this is also thanks for the AI technology, we are able to see and learn where is the parts and successfully pick even layer with some shining surface features. This one, we work with our owner partner, Motion Technique. The end user is Siemens, and you can see again, the products here is quite complicated. The interface here shows Solomon technology is able to define the orientation in different classes. So it has a front view, side view, and bottom view. The robot, UR robot, will place them in a different position to turn it in the consistent orientation. And again, this is also using our AI to learn the parts and to be able to recognize this complicated pattern in the quite a large beam here. Here is the classic example. As I mentioned, we will not have the CAD file to do the matching, because those textile bobbin on the rake, we call the rake application, we do for Taiwanese glass company. We are able to locate the parts after the rake in the position. The bobbin on the rake is still shift their final position. So here we mount our Solomon camera on the end of the robot. We call eye in hand. And like the eyes, we scan the rake. We are able to see where is the final position of the bobbin, and we help them to the rake automation process. Okay. Next one is focusing on the logistics we do for Thailand government. And you can see the layout is we have the automatic warehouse in the back, and the 5 robots here focus on the depalletizing. We mount Intel RealSense in the end of the gripper here, and we are able to locate and identify which carton it is, and we give the center point of the cartons. Okay, and after locating the cartons, we will send the coordinates to the robot, and you will have to program as many as the bugs you want to pick up. So this is the case we can go through with the Intel RealSense to do the eye in hand projects. Okay. So in conclusion, we do believe AI 3D vision give you the wider adaptability in the variable industries. For example, the products, the shape is always changed. You don't have consistent CAD file you can do matching. For example, textile or food or plastics has a feature like that. Or you want to pick up something in the same size or contour, but you are necessary to identify those items by the color or even the text on the surface. Like you are doing some sorting projects, or you are doing some food industry loading, unloading applications. And of course, for the metal parts, I think it's quite a majority market with the complex shape, and those objects are tangled together. In this situation, you can also use in our AI deep learning model to do the bin picking applications with as the accuracy you want scanners. And the fourth is the transparent objects. You could see firstly from the AI, and to define the depth by the our sensor as well. And finally, for the logistics industry, we are able to do depalletizing. We are able to do the piece picking in the e-commerce industry. So those are the 5 categories you can really focus on with Solomon technology. And we welcome a lot of more regional distributor and partners to join us to explore the possibility of the AI 3D vision. Okay, and for the following parts, I would like to introduce you a little bit our interface and some highlights of our software in a technical way. So this is the video we win this year for the Red Dot design, the best of best interface. I'm gonna play for you. Yeah, so it actually has the background voice, but I mute myself here, so I will just explain to you. Yeah, so you can see this is the AI scanner and the robot integration software. In the beginning, of course, we separate a different administration or the operator in a different level to access the software. And you can quickly select the template as you want, pick and place or detection or robot guiding. Those function is ready to use in the functional block on the left-hand side here. And we're doing what we call is coding-free software interface. You just need to drag and drop all the functions you need on the workflow. For example, here I want to capture, I want to do recognition, I want to do some filter, or I want to see the result on display. So in this way, it's really flexible, and you can customize your projects as your text need. So our interface is quite intuitive, and you can visualize everything on the interface, including the AI recognition, or the robot control, or the camera control. And also we provide you the dashboard to analyze your production line with the better result. Yeah, so this is our award winner interface I would like to introduce to you. And we open for the partners or potential partners to try out our software as well. So here are some highlights of our software. I'm going to one by one introduce to you. First of all, again, the visualized flowchart, it allows you to really flexibly use different functional block from the here. You can see I want to do robot recognition, or I want to connect to your PLC. All the functional block is visualized on the flowchart. You can easily select your configuration just like this. We want to provide the customer really flexible communication with our interface. Either you want to communicate with two scanners, you just create another capture. If you want to communicate with different robots, in the end, you can connect to the different PLC block or the robot control block. So in this way, it allows user to maximize your task in the flexible way. Yeah, so you can see all the parameter is already designed in our interface. You don't have to do any coding. You can just adjust some values here, and then you will see the immediately reaction on the robot and the scanner. Second, of course, the calibration is always a headache for the bin picking application. Here, Solomon provides you scanner to robot calibration interface. You would just simply scan, take picture about 15 pictures here, and we will give you the value of the robot and the scanner in the validation, error validation platform. And after a couple points and pictures, you will see if your calibration is successful, or you have to adjust some pictures in the process. So we provide you the interface for the calibration as well. And third is we are able to communicate with camera and the robot directly. So Here you can see we communicate with Kinect, Azure, Intel RealSense, or Solomon camera. You don't have to read the manual on those camera brands. You can just directly adjust exposure time or uh, the some values on the camera, or also some white balance. So those parameters are open in our interface flexibly. And the most important is we communicate with more than 20 robot brands. Um, Here you can see we provide you the interface to control the robot in the 6 axis here. And you can control your gripper, you can control your I/O, for example, sensors or the conveyors. Those mission is able to program on our control panel. So this is really the benefit for some of the users. They are not familiar with different robot brands, or they want to quickly complete a task within a day or a couple hours. You are able to use the Solomon interface to create your mission simply. You don't have to touch the PLC or the robot pendant anymore. This function is really popular for especially some research center, university, or some robot beginner. And of course, if you are the robot expert already, we can also, as a slave, send you the coordinates to your robot controller, and then you can program your robot as you want on the robot controller. The final part is, of course, our AI learning tool. You can see we provide you several convenient tools to define your parts. For example, here we have the yellow color as the front, blue color as the bottom. So this tool will help you quickly define your parts in more than 20 different classes. It's also available. And those label we call annotation. With the annotation, our AI learning model can know what's your objects inside. And later on, with those classes, you are able to pick with orientation, with orientation and with the right classes. And we also understand some of projects you will have CAD file for sure. So in that case, we also provide you the auto labeling tool. Allows you to combine your CAD model into our simulation environment. So you can see here, we will create an environment for you to analyze your objects in the BIM. And we can do offline testing. We can easily create more than the hundreds picture or thousands pictures in the auto labeling tool. So this is really convenient for you to enjoy the AI features deep learning, but also with the quickly labeling method. Okay, so the previous part was AccuPick. Is our major products, and AccuPick focus on, of course, the BIM picking applications in a different industry. But here I also want to give you some of the idea for the slow motion. It's basically the same idea, also using the AI and 3D, but doing the not only a pick and place, but also the robot guiding. So it is really useful for the people to locate the big parts in the 3D, and you can do the sealing, assembling, inspection, or the labeling without fixture. As you guys know, if without the vision eyes, robotic eyes, you have to always fix your objects on the certain position, and the robot will go to the repeated position to do the task. So I bring you an example here. This is one of the example we do in Taiwan. You can see this is the rake, but it's generic rake designed for the every cars. So you couldn't really fix the car position in the less than 10 millimeter, which means from the beginning position to the end position, the car will shift more than 10 millimeter. So in that case, the robot cannot do the repeated job as they want. Reason why we install one scanner here on the top, and we will scan the gasoline door in the back here using our AI deep learning to recognize the car, and also fitting with the point cloud and the CAD file to locate the car. So I'm gonna show you. This is the scanning. And after scanning, I will update the final position of the car and send those coordinates to the robot, update the coordinates, and continuously doing the original task. So as I mentioned to you, SoMotion is aiming on the fixture-free market. Nowadays, the production product is become more variable compared to the past. So really, a fixture is becoming a headache for the user to have to fabricate or to think about how to store those special, unique fixture for their objects. But here, if you have Solomon 3D scanner with the SoMotion technology, you could really locate the parts without any fixture. So this is the idea for the SoMotion. And I bring you SoVision here, is doing the deep learning for the inspections. So as you guys know, traditionally the inspection we call rule-based inspection, which means you have to give the defect definition to define what is the size of defect, what is the color of the defect, and some of time the products or the defect itself couldn't really give you a clear definition. So in that case, you need AI to learn the massive pictures and to help you to classify the defects as a human eyes. So this is why we bring you the SoVision AI deep learning inspection tool. This is only focused on the 2D information. We can integrate with the Bachelor or the tele camera, or we also provide you the SDK for some developers. I will bring you some examples. For example, here, the customer want to polish the surface of the car hood here. And you can see those scratch or the scars are difficult to be defined in the traditional way. And we use the AI deep learning to learn what is the defect painting here. And once we find out the possible defect, we will let the robot know where it is and bring the brush to polish the surface here, as you can see in the video as well. And here we help one of the Japanese customer. They are producing the soup. Those soup with dry vegetable, they have to inspect some of the bigger size or foreign objects in their soup conveyor. I mean the material conveyor. So you can see in the video, our vision also help you to identify what is the big size. And this big size, you will have difficult to use the rule-based programming way. Instead, here we use the AI learning to teach the computer what is the wrong size and what is the acceptable size in this case by the AI deep learning. Two other examples here. For example, PCB board. We can inspect where is the different from the sample compared to the golden sample here. You can see some label is missing, some components with the wrong color or orientation. It will be easily to recognize by the AI. Or here is another interesting case. We are inspecting the egg, the shell of egg into different level, grade 1, grade 2, grade 3. You can see the crack on the shell is different, right? So if with the serious crack, they will deliver to the near distance customer. And this is only done by the AI possibility, because it is also hard to define what kind of the crack you want to put into the grade 3, because those cracks are born in a natural way. So you can learn by the pictures, not by the programming way. The final product is the SoScan. It's our Solomon scanner. It's relatively easy. We provide you this scanner to do the measurement, 3D matching, or some reverse engineering. It's really open source camera for the developer to use in different applications. We will generate you high quality point cloud and in the various format, CAD file or some STP file. You can do the engineer application as you want. Yeah. So this is the SoScan. Bring you 3D scanner. Okay. So today we bring you in total 4 products. Start from the AccuPick bin picking and the Soul Motion with the robot guiding. These 2 products are focusing on using the AI technology to locate the parts and using our Solomon scanner or the third-party scanner to see the depth and to finally define the picking points for the robots. And also we bring you the Soul Vision to inspect your parts. Compared to the rule-based programming way, we provide you the AI learning way to analyze your pictures and to provide you like a humanized inspection method to help you to conquer the task you couldn't do in the past. And finally, we have the 3D scanner to provide you the good quality point cloud in which you can use for your reverse engineering, measurement, or 3D matching applications. And for the pricing and more product information, we will send you the email, or you want to experience the software online or offline, we will give you the customized package. Also, we will one-on-one to consulting with your applications. Thank you.
Thank all of you for joining. Hope you can join next time, and just follow us on any social media. We're on LinkedIn and also on our website, and we will be posting all of the information about coming webinars.